Okay, good morning, afternoon, or evening, everybody. I've got 2 p.m. Eastern Daylight Savings Time, so we are going to get started here. Welcome to the Explore, Discover, and Access Snow and Ice Data with the new NASA National Snow and Ice Data Center DAAC website Earth Data webinar. This is your host, Jennifer Brennan. Again, it is 2 p.m. Eastern Time, so we are going to get started. What I like to do first is begin the event with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any questions or you have any issues, what I'd like for you to do is enter those into the Q&A panel, and you'll find that on the right side of your screen rather than the chat. Today's webinar is being recorded. The recording will be posted both to the NASA Earth Data website and to our NASA Earth Data YouTube channel within a week of completion. Once completed, I will send an email to all registrants that will include the recording links and also a link to the presentation slide deck used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour and 15 minutes long, with 1 hour allocated to the presentation and demonstrations and an additional 15 minutes for it's actually 1 hour long with 45 minutes for the presentation and demonstrations. There is an initial 15-minute Q&A period, but we do reserve the right to extend the Q&A of an additional 15 minutes depending upon the volume of questions that we receive. During today's webinar, we have 2 speakers. Our first speaker is Leslie Goldman. Leslie is a user engagement specialist at NASA's National Snow and Ice Data Center Distributed Active Archive Center, or NSIDC DAAC. Our second speaker today is Gail Racase. She is a data support specialist also at NSIDC DAAC. And now what I'd like to do is actually pull up today's agenda. Okay, Leslie will begin today's webinar by providing an introduction to the DAAC, the new website organization, and general resources for data users. And then from there, she will showcase 2 key cryospheric data visualization tools on the Visualize Data page, the satellite observations of Arctic change, and also the Charctic interactive sea ice graph. We will then transition back over to Gail for a more in-depth look at Charctic. The next section of the webinar will focus on data discovery and data access. Leslie will kick off this segment by discussing ways to explore data by parameter, by the whole catalog, or by data collection, and show you how to download data from an ICESat-2 dataset landing page using the NSIDC DAAC data access tool. After this, Gail's going to lead you through a Jupyter Notebook, command line data discovery and access tutorial, again, focusing on the same ICESat-2 dataset that Leslie had covered. Leslie will wrap up today's webinar, and then we will transition to another optional set of final polls. I usually give these polling questions approximately 5 minutes or so before we move to the Q&A session, but the questions will be open much longer for those of you who would like to provide feedback. And then from there, we'll jump straight into the Q&A period. Depending on the volume of questions we receive, we'll extend the Q&A period an additional 15 minutes from end time for those of you who are able or who may wish to stay on the line, but we will have a hard cutoff of 3:15 p.m. And just a really quick note about the Q&A period. We will try to answer all the questions within the time allotted, but if we're not able to address your question during Q&A, our speakers will be able to follow up with you offline. And so with that, it is my pleasure to introduce today's first speaker, Leslie Goldman. Leslie, and I'm going to stop sharing at this point, and I am going to toss the presenter role down to you, Leslie, and you can get started. All right, well, thanks so much, everybody.
Thanks, Jennifer. I'm going to share my screen now and set this to presentation mode. All right, so we have a lot to cover today, so I'm just going to dive right in. As Jennifer mentioned, I wanted to give a brief introduction about NSIDC DAAC. So the National Snow and Ice Data Center is part of CERES, the Cooperative Institute for Research Studies, which is based at the University of Colorado in Boulder. Our expertise is in data management and research to advance knowledge of Earth's frozen regions, also known as the cryosphere. The cryosphere is a global system stretching from the Arctic to the Antarctic and includes all the snow, ice, and other frozen regions across the planet. Our data management and research activities are funded by NASA, the National Science Foundation, and NOAA. The NASA DAAC at NSIDC is our primary NASA funding. The NSIDC DAAC is one of 12 discipline-specific distributed active archive centers. Our categories include things like frozen ground, glaciers and ice sheets, ice shelves, sea ice, snow, and other related geophysical measurements. The total NSIDC data catalog is over 1,400 data sets, and approximately 750 of those data products are NASA NSIDC DAAC products. So the image I'm showing here on the right is a screenshot of the NSIDC.org DAAC landing page, where you can explore specific data and resources from NSIDC DAAC, learn more about the DAAC, read stories about data use cases, and then also get data update announcements. Our data come from NASA's past and current Earth observation system missions and projects. The data come from things like satellite missions, airborne field campaigns, and ground-based measurements. Oops, went back. So this is just some of the collections that we archive and distribute for NASA. I've highlighted a few here to point out. So Nimbus, which is in the sort of orangey peach color towards the bottom of the table. This is a collection of some of our oldest data. So the temporal coverage is 1966 to 1970. Our longest temporal coverage data collection is the SMMR, SSMI, SSMIS collection, which is passive microwave data spanning from 1972 to the present. And then our most recent addition is the ISAT-2 mission, which is altimetry data. That satellite mission began in 2018, and we are providing data from that mission from 2018 to present. As you can see, a lot of our spatial coverage is global because we have satellite mission data, though we do have some collections that are more polar focused. And now what I'm going to do is load up the website. We're going to cover overall organization and general resources on the website. We're going to start kind of broad and then get more specific to data users. After we go through these higher level resources and sections of the website, as Jennifer mentioned, we're going to do 2 specific data visualization examples, and then we will explore our data and work with an ISAT-2 data set to download and access it. So I am now going to move away from my presentation and open up a web browser. So the main NSIDC website is simply NSIDC.org. And this is a new website. We launched it at the end of July. So we do have a little welcome message here with some information about just that things might be changing as the website stabilizes. So to start with, I wanted to orient you to our main navigation. You can see that we have news and analyses. So NSIDC does data management and research. I'd like to point out the scientific analyses section. So we do have data images and analyses on snow, polar ice sheets, and Arctic sea ice. These are blog sites that have data visualizations as well as articles using NSIDC DAAC data as well as other data sources. We have a data menu, and this is where we're going to spend more time later in the demonstration. A section about the research at NSIDC. Another section I like to point out is this Learn menu. So, part of our goal is to both educate and broaden awareness and use of our data and research in the cryosphere. So we have developed over the years a lot of educational resources about what the cryosphere is and the parts of the cryosphere. When you click on these sections, there tends to be an organization of an overview, the science, why this particular feature of the cryosphere matters, and then quick facts. And if we click on the science here in this lower navigation and scroll down, we also try to include information about research and data at NSIDC that are related to that particular cryosphere research. You can also click on these breadcrumbs to get back to different parts of the website. So if you wanted to see the full Learn page, you can click back into the breadcrumbs to get there and see your options. If I go back to the home page, just briefly scrolling down, we do have these icons that are our sort of key geophysical measurements. here that you can toggle on and off. If you were to click on glaciers, for example, you can see a little information about glaciers, and then you can explore all the glaciers data at NSIDC. You can go to the Learn section, or you can look at specific data collections that house glacier data. Okay, so let's see, we're going to go to our data menu now and look at some of our new resources. We have a new section called User Resources. And in this section, we have a Getting Started with Data page. This is a great resource for someone who has never been to the website before, or perhaps goes to our data catalog and is overwhelmed by the volume of data sets listed. And it gives you an introduction to how to navigate the site, how to access the data, things like that. We also provide data announcements whenever we release new versions of data or publish new data. We also have a help center that I'd like to point out here, where we have help articles. A lot of these help articles are related to specific data sets or specific data collections. So you can filter these articles by a data collection. You can filter them by topics like APIs, or if you're interested in articles that feature Python and R. And then we also provided a how-to filter. So if you want to look at articles for how to reproject and regrid data, you can search that way as well. These articles are also, if relevant to a specific data set or data collection, you can also find them on that particular data set landing page or collection landing page, which I will show in a little bit. In the quick links on this right-hand side, we also have a link to our NSIDC interactive code tutorials, and this will take you to a GitHub repo with all of our current code tutorials. Okay, and if you want to get to that DAAC landing page that I showed in my presentation, that's under Data Programs, and here you can see the DAAC site with specific featured information for our DAAC users. Okay, so next we're going to click on Visualize Data. These are tools that have been built over many years, but we've compiled them into one easy to look at page of featured data visualization tools using our data. And we are going to scroll down. We're going to check out this Charctic interactive sea ice graph, as well as this satellite observations of Arctic change. And I'm going to start by clicking on that SOAC tool. Okay, so we land on a page that says Explore Maps, and then there's also another page that describes the tool itself. So these maps are generated from passive microwave data collected by NASA Earth observing satellites, and they are maps of the Arctic. We're going to click on Sea Ice Age today for this demonstration. And you can hopefully see my screen is loaded. At the top, it says Sea Ice Age time series by month, October 1985. The lighter green on the map is indicating younger sea ice, and the darker blue is indicating older sea ice. If we look a little bit lower down on the right, where it says ice extent by age, this is a bar graph over time that is showing Octobers from 1984 all the way up till 2015. If you want to change the month, you just click on where it says October, and you can pick a different month, say March, and the graph will update, and so will the map visualization as well. You can also see in the lower left corner an animation bar. It's at 1985 right now. If I scroll, drag my cursor on that animation bar, the map will update to show us the data from the year that I stop on. And then if I click the play button, it will actually animate through time, and you'll see the bar graph changing as well as the map changing. So I'm going to pause that. Below each of our maps, we do have information about the map itself, the color key and bar graph, how to interpret it and use it, how to change the display. And then we also include information like what is sea ice age, why does it matter, what the data are showing, and we often include questions that can prompt people visiting the page to interact with the tool itself to answer the question. So these are some prompt questions that can be useful. You know, if you're a researcher who is also teaching, this is a great tool to share with your students to get them interacting with NSIDC DAAC data and starting to understand how the cryosphere is changing over time. At the bottom, we have data sources. You can see here where it says explore the source data for this map. There's a link to the dataset landing page. If you click on that link, it will take you to the dataset landing page that was used for that particular map. And we'll go into more detail in a little bit about these pages, but I did want to scroll down and show you that under data access and tools, this first option is to download the data, access the data directly, and the second one will link you right back to the tool. Next, we're going to go back to visualize data, and we're going to scroll down and we're going to pick the Charctic Interactive Sea Ice Graph. So this is a really popular tool that allows you to select and dynamically graph Arctic and Antarctic sea ice extent over months. This tool is actually housed on our Arctic Sea Ice News and Analysis site, which provides analytical articles about sea ice or change over time, as well as other tools and images of data. But right now, I will hand this back over to Gail, and she will give us a little description of how this tool works.
Gail, we can't hear you.
Thank you, Leslie. So this is Charctic. It's one of our most popular tools with users. This interactive graph shows sea ice extent in millions of square kilometers over time. Sea ice extent is the area of the ocean which contains a 15% or greater concentration of sea ice. So you can see on the vertical axis over here, here's the extent in millions of square kilometers. The horizontal axis shows you months of the year. And then in the right-hand column, users can pick years to display. The earliest measurements in 1979, and the most current just yesterday, August 23rd, 2022. So the default graph will show in a dotted red line our record minimum sea ice extent. In gray is the median sea ice extent calculated from 1981 to 2010, with shaded areas in gray for the interquartile and interdecile range. Our current year will be tracked in a light blue solid line, so you can compare it to the record minimum and the median. So some of the interactive features of this graph is the user can switch between the Arctic and the Antarctic. They can change the month which they're interested in starting their analysis with. Like I mentioned, they can choose the years they want to display, or all years. And finally, they can change the color palette that best suits their needs. So now I'll just hand it back to you, Leslie.
Thanks, Gail. So here we are, we're on the Charctic tool, similar to the SOAC tool or satellite observations of Arctic change tool. If you scroll down, there's information at the bottom of the page that explains how to use the tool. And you'll see the second to last bullet says, for more information about the data, see about Charctic data. And on this page, it explains what data are being used. Again, if I click on this sea ice concentrations one, it will take us back to a familiar dataset landing page, a different one this time, but this is the dataset. that is being used for Charctic. Again, if you scroll down into data access and tools, I believe you should see a link to Charctic from there. We will get to this page and how it works in just a minute. Before we do that, I'm going to navigate back to the home page by clicking on that NSIDC logo in the top left corner. And now we're going to dig into ways to explore the data. So obviously you can go to the data menu and click Explore Data. You can also just click this Explore Data button on the homepage itself. And this takes you to a landing page that gives you multiple options for how to search data. So if you know specifically what you're looking for, you can type it here into the search data bar. If you're not sure what you're looking for, you have several options to start narrowing down your results. So the first way you can look for data is by looking at our data collections. The second way is by our main geophysical measurements. Again, you will see here, you can explore the data or you can learn about the cryosphere feature. And then the last way is the all data sets, which is our big data catalog. When you click on all data sets, it will load like this, and you can either type in a search term or you can just click the search button and it will load the catalog. We do have a Earth Data webinar about this data search tool in particular that's a few years old, but it's a great one to watch if you want to learn more about why this tool was created and how it works. I will not go into great depth here, but I will point out, on the left-hand side, there are quite a number of different ways that you can narrow down your results. And if I scroll down to the bottom where it says program, you can see the NASA NSIDC DAAC has approximately 764 data sets available currently. And if you click on any of these title links, you will get to the dataset landing page for that data set. If I go back to Explore Data, I will now show you guys data collections, and I'll begin our process of navigating to a specific data set and accessing and downloading the data. So, as I mentioned, if you go to nsidc.org, you can click on the Explore Data button on the homepage or get to it from the data drop-down menu. In this particular example, we are going to look at our newest mission, the ISAT-2 mission. And I happen to know that that's a satellite mission, so I can filter my results down here to satellite. You can also see that you can narrow your search results down to geographic area or specific geophysical measurements. And we'll scroll down this list to see if we can find ISAT-2. So here it is, ISAT-2, data from the ATLAS instrument used on NASA's ISAT-2 satellite mission. Data products in this collection describe elevations of sea ice, land ice, forest canopies, water height, urban areas, and more. The data observations span from late 2018 to present. Something that I also want to point out is you'll see right below ISAT-2 is ISAT GLASS. This is a data collection of data that spanned from 2003 to early 2010. And the data are quite similar to ISAT-2. This was actually the original ISAT mission. And when the mission ended in 2010, NASA created the NASA IceBridge mission, which was a airborne remote sensing mission that spanned the years between the end of ISAT GLASS and the beginning of ISAT-2. We also house the IceBridge data collection at NSIDC DAAC, and that's in this list. So I'm going to click on Go to Collection to go to the ISAT-2 collection. So our collections always include at the beginning a description, a high-level description of what is in the collection, the span of like the data observations. If you scroll down, we also do things like link to related collections that NSIDC DAAC hosts. We also have images often of how data are being used. So these are images from ISAT-2 data. And in this particular one, there is a really neat NASA Scientific Visualization Studio website of ISAT-2 data visualization. So we link to that gallery for users to explore. if they're interested. So in our data collection, we have on this right-hand side, we're on the overview page. If there's technical documentation related to the collection, it's listed here. Help articles, tools that can be used with data from this collection, any data announcements. Published research is a list of citations that we are aware of using data from that particular mission. In this case, we also have some product overviews because ISAT-2 is such a new mission. There's a nice graphic explaining the different types of data products available from the mission. And we are going to click on this data, which is always the last link in any collection menu. And you can see here that there are 28 data sets in this collection. If you click this Explore All Data, it will take you into the data search catalog with this particular mission, those data sets loaded so that you can then expand out your search if you want. You can see that you can apply this filter to search by current version. Right now, though, I'm going to scroll down and look at my options, and I'm going to pick this Atlas ISAT-2 Level 2A Global Geolocated Photon Data. We can see that it is terrain elevation data, and that the data set ID is ATL03. We often call it ATL03. And I'm going to load the data set landing page. You'll see at the top we have messages that keep popping up and changing. So if there are any messages specific to a page of the website, we will add these notification banners. And on the top right corner, there's a little arrow where you can toggle it closed so that you don't have to see all those messages while you're looking at the page. I do want to point out, though, that we actually do have a major update starting today in, this is Mountain Time, so 2 o'clock Mountain Time, that will span through Friday this week, where we're making some changes to our back-end system, and the data set landing pages will be available. However, you won't be able to access some of our data. So after this webinar, I encourage you to go look around and explore our site, but just be aware that you may not be able to download some of our data for a couple of days. Okay, so we're going to scroll down this page now, and let's see. I'll start at the top with these icons. So we do provide user support for all of our data products. And in fact, if you ever have a question when you're on a page, there is a support button in the bottom right corner where you can always contact us. And this goes to real life people who are our user services support team, or in our great, wonderful group of people to help you out. We do, however, have like a range of level of service for our data products. So in this case, we have a comprehensive level of service. And if you're interested in what all the levels get you, we have a page explaining it all right here. So just the basic versus standard versus comprehensive. But as I said to begin with, we always provide user support for all of our data. The next icon here is our subscribe button. So if you fill in your name, your email address, and click submit, what you will get is email updates for this specific data set, ATL03. This is something that you need to sign up for at the individual data set level. So if you're interested in 6 different data sets, you would fill this out on each data set landing page to receive updates for just that data product. Next, we have a citation. So NASA does require that everyone use citations, properly cite the data in their publications. To make this easier for you, we include the citation in DOI at the top of the dataset landing page, and we give you some options to choose from, whether it's APA, Chicago, or BibTeX, and then you just copy the data citation in order to save it to your desktop. And then last, we often have user guides. This will open a downloadable PDF user guide that you can look at in your web browser and then choose to download. Again, you'll see the citation on the front page. We do update these guides periodically. So we always include a last updated date in the PDF. And if you choose to download the PDF, I always encourage users to come back if they're going to revisit the data to see if there's a newer guide that they should be looking at. Okay, so now we have this tiny little, this is the most recent version of our data. So if you happen to land on an older version of a data set, this little sentence will point you to the newer version. And we often have summaries describing the version itself. Next, we have an overview and this right-hand menu that takes us down the page. So this is overview information to help the user decide if they want to use the data, so they can see that it's terrain elevation from ISAT-2 using the Atlas instrument. The data format is HDF5, and then some other information about coverage and resolution. You can either scroll down the page or click on the next item to get you to the next part of the page. So now we're at the data access and tools. For those of you who are familiar with our older website, this is a brand new section. And you can see here, it says a free NASA Earth Data login account is required to access these data. So this will always appear if you're on a NASA dataset landing page at the NSIDC DAAC. This is a free account, but it is something that NASA requires in order for people to access the data. And then we list cards of different services and tools for accessing and working with the data. We include these badges to help people sort of narrow down what they're looking for. So, this HTTPS file system is to get the data access tool. You can get the data and you can do some search and discovery within the tool. And we have quite a long list here, but we're going to stop right now and look at this data access tool. I'm going to click on it, and it is going to open the NSIDC DAAC data access tool. There is a help article linked at the top in case you want to learn about how to interact with this tool. You can see that it's loaded the ATL03 data product that we were just on, and you can now do various things like filter by date, use a spatial bounding box. You can click on the map and see, and you can select an area. There are lots of different things you can do with this tool. As I select an area, you can see the right-hand side of the page is updating with files. This is the file list for the area that I have chosen. And if I scroll down to the bottom, it says I have 1,979 files, which is over 3.8 terabytes of data. And that's a lot of data. So the first thing I need to do, though, is log into Earth Data. So if I click on this button, it already remembered me, so it logged me right in with my credentials here. And the files are loading again. So there are a couple of different ways that you can download the data. First, I'm going to narrow my search a little bit here and see what we can find. So you'll notice at the bottom, these 3 orange buttons. You can download a Python script, you can order files, or you can do a large custom order. The large custom order is for files that are over 2,000 files. And then the sort of direct download is for files under 2,000. So right now I have far too many files to do. Well, actually, it looks like I can download them, but I don't want to download this much stuff to my computer. So I am going to show you guys a little trick that can be handy. If you just are interested in one particular file, you can highlight that file name, copy and paste it into this search box. The list will update to just that one file, and then you can download it to sort of look and sample the data. So if I click the download script, it will download a Python script. If I click order files, it will ask you to confirm your order. And then if I click OK, it has placed my order. If I click on this little arrow here, you'll get an email that tells you where to go. But if I click on this link here, I go to my order history page. You can see that I've downloaded things in the past. This is our most recent one here, 8/24/2022, 12:30 p.m. If you click on the row, it expands information below it where you can then have options to download the data. If we go back to the tool and you click on large custom order, this will redirect you to Earth Data Search, which is NASA's main data portal for all the DAACs. So it allows you to search NSIDC DAAC in context with all the other 11 DAACs and their data. It also gives you more options to further customize the data that you're ordering. I'm not going to do that right now. So that's our data access tool. It's available for most of our NSIDC DAAC data sets. If I close this up and we go back to our dataset landing page, we are going to scroll down next to look at our customized programmatic data access service. Here you can see, again, we can get data with this and we can customize with this. Whenever there's a customized badge on a card, you can expand the card to learn more about the customization capabilities. So we've got some data reformatting, spatial subsetting, temporal and variable subsetting. If you click on the title, in this case, because it's about programmatic access, it's going to take you to a guide with lots of different ways that you can programmatically access the data. For today's demo, and this is going to be the final portion of our presentation, Gail is going to lead us through the data access using the Jupyter Notebook. So I'm now going to hand this back to Gail for her to begin our tutorial.
Thank you, Leslie. I'll unmute myself first this time before sharing. All right, picking up from the ATL 03 version 5 landing page that Leslie showed us, I'm going to show you how I got to the notebook. So as Leslie pointed out, scrolling down to the data access and tools, we look for the customized programmatic data access service card and click on programmatic data access guide. And then we look for the data access Jupyter Notebook, like Leslie showed us, and then click one more time on explore the NSIDC data access notebook. And that takes us to the NSIDC GitHub repository. Now this repository shows us multiple methods for interacting with the Jupyter Notebook. You can use Binder, Docker, and if you're interested in then the different options for on a Mac or Windows machine. So if you're interested in using those methods, instructions are here on the GitHub page. To orient you with what I've done is I've cloned this notebook into a Jupyter Lab environment, which you see here. And that's what I'm going to use to run through this Jupyter Notebook. So here you see the customize and access NSIDC DAAC data Jupyter Notebook loaded. So in this tutorial, we're going to discover what data is available for an ISAT2 dataset, customize it, and then go ahead and download it. Now, the really neat thing about this notebook is while the code blocks are written in Python, the user doesn't need to know any Python code in order to run it successfully. As you'll see when we go through the notebook is going to prompt the user for the inputs it needs. So the first step is importing the packages. So this is just going to import all the Python modules it needs to successfully run the notebook. A couple of note are JSON, GeoPandas, and Shapely, which are going to help me geospatially manipulate the data. And also you'll see statistics down here, and that'll just allow me to run some really basic mathematics operations. So I'm going to go ahead and run that code block, making sure my Python 3 kernel is running. All right, and when you see a number by the code block, that means it's successfully run. So as Leslie mentioned, all of our NASA data sets hosted at the NSIDC require an Earth data login. So this notebook is prompting me for my credentials right off the bat so I can interact with the data without any problem and download it. So first it asks me for my username and then my password. and finally the email address associated with that account. Now I'm going to select the data set and determine the version number. So here, the notebook is just going to ask me for the data set I'm interested in, the short name of the data set I'm interested in. So running this code block, I'm going to use the data set that we've been talking about, ATL03. Now here, this code block is going to run a query against our common metadata repository and check for the latest version of that data set and use that in your notebook. So running that code block, it tells me that the most recent version of ATL03 is 5. Great. So now we're going to start customizing that data set. First, we're going to select the time period of interest. So for this tutorial, I wanted to limit the number of outputs. So I'm just going to narrow it down to the first of the year of 2022. So running that code block, it prompts me for the start date. So 2022, and it shows me the format it wants it in. So 2022-01-01. Now it's asking me for a start time. So I'm just going to pick midnight. Now it's asking for an end date. So 2022-01-02. And then again, midnight in hours, minutes, seconds more. The format is, it is important to use the correct format. I've gone through this notebook before and had my format incorrect and it doesn't work. Next, I'm going to select my area of interest. So here I have two options for entering my area of interest. The first is entering a bounding box in decimal degrees. And my other option would be to enter a vector, or would be to upload a vector-based geospatial file, such as a GeoJSON, an Esri shapefile, or a KML. So for this demonstration, I'm going to go ahead and stick with the bounding box, and I'm going to use the example that's given here. So that's just going to encompass the state of Colorado. If I wanted to use the vector-based geospatial file, I would leave this, I would leave the prompt blank after I ran the code. So running the code is prompting me for that bounding box, which I copied, and now I'll enter it. So as I mentioned before, if you don't want to use a bounding box and you have a vector-based geospatial file all ready to go, you can go ahead and use that. We would load it to the shapefile folder, which is already preloaded with the notebook, and you would modify this code block a little bit, and you would use it would leave the bounding box blank. In this case, I'm relying on the bounding box coordinates that I've entered above, but I'm going to go ahead and run this code because it has some definitions in the code that the notebook is going to rely on later. All right, now we're going to determine how many granules exist over this time and area of interest. So this again is going to ping our common metadata repository and show me how many granules are available for the first of this year over Colorado. So running that block of code, it lets me know that there's one granule of ATL03 version 5 over my area and time of interest. Now we're going to determine the average size of those granules as well as the total volume. So if my output was multiple granules, not just one, it would average them all together and tell me the average size of each one of those granules, and would also calculate the total size if I downloaded them all. But in this case, since I only have one granule, it's just going to tell me the size of the one granule. So running that code block, it lets me know that the average size of each granule is about 650 megabytes, and the total size of all the granules is 650 megabytes. Now we're going to go ahead and get into some of the customization options. So we're going to select the subsetting, reformatting, reprojection services enabled for your data set of interest. So those customization options will include spatial subsetting, temporal subsetting, whether or not you can reformat, and whether or not you can reproject your data. So right here, this query is just going to query and find out which services are available for my data set and area and time of interest, and then it will use that information in the code block that follows. So running that, now the notebook knows what customization options are available, and now it's going to walk you through and ask you which ones it wants to use. So running that code block, it lets me know that subsetting by bounding box based on the area of interest inputted above is available. And it asks me, would I like to request this service? So let's go ahead and say yes. Now it says subsetting by time based on the temporal range inputted above is available. And would I like to use that service? Sure, let's say yes. Now it tells me that the reformatting options available are tabular, ASCII, and NetCDF. So if you'll remember, also the native format is available, of course, which was HDF5. And if I leave this blank, it will return the native format. So I'm going to go ahead and do that, leave it blank, and my granules should be returned in HDF5. And then it lets me know that no reprojection options are supported with my requested format. So given the customizations I've already done, I'm unable to reproject the data. So good to know. Now finally, we're going to select, we're going to explore variable subsetting. So some of our data sets have extensive variables in their outputs, and ATL 03 is one of those. The ISET2 data sets are known for having lots and lots of variables. So maybe I'm not interested in all of those variables and I want to narrow that down. So running this code block, it lets me know that variable subsetting is available for the data I'm requesting, and would I like to subset a selection of the variables. So if I say yes, it's going to list all of the variables available with this data set. So I'm going to go ahead and say yes. And as you can see, ATL 03 has a lot of variables. A lot. So since this data set, its main parameter is terrain height, I'm going to select one of the height variables, although in reality, you would probably want to select more than just that variable, but just for demonstration's sake, I am going to select one of those variables. So right here, with ground fact 1 left, I'm going to say heights. Now it's important to copy the whole variable, including the slashes. And then, sorry if I'm making you dizzy. I will enter that right here in this box. And if I want to enter more than one variable, I would copy and paste all of them and separate them by columns. All right, so now we're done customizing our data. And now we're going to move into some of the ordering parameters. So first we select the data access configurations. So this is just going to set up our ordering method. If I have less than 100 granules, then it will set up a synchronous request, which is a continuous, requires a continuous connection. If it's between 100 and 2,000, it'll be an asynchronous request, which will allow other users' orders to be interleaved in between. And if it's over 2,000, it will be broken up into multiple orders. So it lets me know there'll be one total order processed for this request. Now we're going to create an API endpoint. So running that, you can see the API URL, all the parameters, customization parameters I've ordered, and then my username. And now we're going to go ahead and request the data. So running this, we'll go ahead and place my order. And you can see the progress of my order. And it says downloading, and my download is complete. So popping over here into my outputs, you can see, and I'll just move this over for a second. You can see there's my customized granule returned in that folder. And very last, this just cleans up the folder in case any extraneous folders or files were created. It's not really necessary for this demonstration, but I'll go ahead and run it. So just to wrap up, we've explored data availability and volume over region and time of interest, discovered and selected data customization options, constructed an API endpoint for a request, and went ahead and downloaded the data. And that wraps up our tutorial, and I will hand it back to Leslie real quick.
Thanks, Gail. And that actually wraps up our presentation. I know we want to be able to move to end poll questions as well as any questions from the people attending. So I will hand it back to Jennifer. Before, I will just briefly say, if any of you are using an NSIDC DAAC data, we're always looking for stories to promote how the data are being used, and you can always reach out to us on our website by clicking that support button to let us know. I'll now hand it back to Jennifer.
Okay, thank you so much, Leslie. At this point, I think what we'll do is we'll give these polls just a minute or two, but I will leave them open for 30 minutes or so, so that we can move directly to the Q&A. At the moment, I am not seeing any questions. So folks, if you have questions, please feel free to enter those into the Q&A panel. You should see that on the right side of your screen with the chat and also the optional final polls. And I really appreciate your feedback on the polls. This helps us as we determine future webinar topics. And so thank you so much for those of you who are interested in providing feedback. It is very much appreciated. And so why don't I give this another minute and a half or so, and then we'll move directly to the Q&A. All right, thanks so much, everybody. Okay, at this point, everybody, we'll leave the polls open and we will move directly to the Q&A. Let's see if we've got any questions here. All right, the first question is it possible or will it be possible to be able to work with some of these data sets without having to download them? Can you hear me?
Yeah, I was curious about, so this is Leslie. I was just wondering if Gail or or Lisa are interested in answering that question.
Hi, yes, this is Lisa. We are working on moving data sets to Earth Data Cloud. So later this year, that will be possible with a select set in the cloud if you're used to working with Amazon Web Services.
Okay, thank you so much, Lisa. I am just scanning to see if there are other questions, and let me also take a look at the chat. And you're welcome, of course. Does anybody have any questions? Okay, well, while we're giving this just a couple of minutes, what I wanted to do is just remind everybody that within a couple of days, it'll probably take closer to 3 days or so, we will have the recording available on our NASA Earth Data YouTube channel. There you can find over 100, probably over 140 at this point, data discovery and data access webinars, and I will identify the link for the webinar that was mentioned earlier and put that in the chat for all of you. We will leave the polling questions open again for another 20 minutes or so. Let's just see if there's anything else in terms of questions. I don't see anything else. I will send a follow-up email to all registrants that will include a link to the few introductory slides that were presented at the very onset of the webinar, as well as a link to the recording so that you can go back and reference the recording at a later date. The slides do include links to the Jupyter Notebook, as well as all of the other information that was presented today, and I will include some of those links along with the recording in our YouTube playlist. All right, so I'm going to do one last check here. Let's see. And of course, if you have questions as you go through this content or explore the datasets, please feel free to reach out to the NSIDC DAAC directly. They will have information on how to contact them on their website. I'm just looking, I don't see anything. Let's look one more time. Well, okay, well, I really would like to thank all of you. We are going to leave the virtual meeting space open. And thank you to our speakers, Gail Ricase and Leslie Goldman, for their time this afternoon, and for all of you for taking time out of your day to join us. And I'd also like to thank Lisa Booker, who works in user services at the NSIDC DAAC, for being available for the Q&A panel. All right.
Thank you so much, Jennifer.
You're quite welcome. One last scan, and I don't see any additional questions. And so thank you very much, everybody. We'll log off from the audio component, but I'll leave the space open. If you think of anything, please feel free to add it here. I will forward the Q&A log and the chat along to our speakers so they can most certainly follow up with you offline if needed. All right, thanks so much, everybody. All right, goodbye now.